Okay, we are now on question 4. This is some sort of governor. What is this type of governor called?
Centrifugal governor, and it is called the. How do you say that?
Okay, so in the textbook there are different types of governors. There's a Watt governor, there's a Proulx governor, there's a Porter governor, and so on and so forth. If there are 3 or 4 governors, and I give you a particular governor in the mock exam, obviously I can't give the same governor in the exam. It could be similar, or there could be some modification to it. All right? So remember, the mock exam is to give you guidance on a particular type of problem. What that means is I won't give you the exact same governor, but I will give you a governor that looks very similar. So I'm not going to say which other governor there is. There's a process of elimination. If it's a Porter governor in the mock exam, it must be a Proulx governor. If this is a Proulx governor, then maybe it's a Porter governor in the exam. That's a hint. So I'm saying, what is this governor? It might be something like this, but different.
Okay.
So figure it out. But the same underlying principle still applies. So carrying on, just to clarify what's going on over here. We have some sort of central spindle. There's some fixture on this side. There is a sleeve that has a mass capital M. There are 2 balls on either side, each with a little mass of M. There's a gravity force over there. There's an outward centrifugal force, and this is spinning around, and based on the centrifugal force and gravity force, it is in equilibrium. And then in the question, I specifically say, this is the formula for the centrifugal force, and I say something about you have to take equilibrium of moments about a certain point. Okay, what is your name? Carry on, whatever.
Okay, my name is Shikina.
Okay.
So I called this alpha.
Yep.
And then I came all the way here. Then I came up with beta.
Okay.
So with the alternative angle, this was beta also.
All right. It's not very clear. Can you use the green marker? I can't see on the video.
Okay. So this was alpha.
Right?
And then here, I came up with an angle beta.
Okay.
With an alternative angle, this was beta also because it is Z.
Both are vertical and they're parallel. Okay.
And then this is alpha.
Right?
And then the next thing to do is just to take a moment.
Okay.
I have this, and then I have a mass here, right? Just put it down here. This is a small m.
Okay.
So I take a moment about point I.
Right?
And then I could call this probably B, this point here.
Okay.
I call it B so that I should get the length properly.
Okay.
So when I take my moment, so it's going to be F times the perpendicular radius, which is going to be BZ.
Okay.
So I assume that moment going this way is positive,
Okay.
so moment going the other way will be negative.
Okay.
Sum of moment is equal to 0. So m multiplied by this distance here, Iz plus mg multiplied by this distance here. So this is y, and then that's I, so big M.
You just scratch it off, put the big on top. Yeah, that's fine.
So this will be multiplied by I. Right? I decided to divide everything by BZ. Then my F, my centrifugal force, will be equal to RZ. So if you notice that the distance IY is the addition of YZ plus ZI. So I want to write this in that form.
Okay.
And I go
Okay. Just give me the marker. All right, you can take a seat, and I'll just quickly comment about how it looks. All right, let's see if I understand what's going on over here. All right, so you've put everything in terms of the IYs and IZs and so on and so forth. There's nothing wrong with that. But you need to specify this is the length L1 and L2, or L3 or L4, whatever the case is. So that will give you not the full marks, but it'll give you a reasonable amount of marks. Out of 25, this will probably be about 16 marks or thereabouts.
Yeah, but I haven't finished yet.
Okay. Were you able to finish?
Yeah.
Okay.
I was able to finish.
All right. So let me just see if I understand the reasoning around it. So I said in the hint you must take equilibrium of moments about point I. So basically the anti-clockwise moments is equal to the clockwise moments for equilibrium. So you took the force F, the centrifugal force, and you took the perpendicular distance, that is a counterclockwise moment, and then you said that counterclockwise moment is equal to the sum of two other terms. There's a term because of the little mass m, but you didn't put the g, so you needed to put the g. All right, so the centrifugal force is on this side. It's exerting it this way. It's going to give you a counterclockwise moment. That makes sense. There's the mass because of the ball. It is going downwards. The mg, little mg, is then going to give you a clockwise moment. That's fine. And then there's the sleeve mass, but then this would be wrong because the sleeve mass is half of the mass on this side and half of the mass on this side.
So
Based,
divided by 2.
yeah, based on the symmetry. So there's a physical block of metal with a hole in the middle, and it's pushing down. You assume radial symmetry. So you assume the little ball on that side is m, and the little ball on this side is also m, which is the case. And this big mass, you just assume it's symmetric. And half of the mass is on this side and half of the mass is on that side. So you then divide it by 2, okay? So this weight over here is coming down, and you multiply it by this distance from here to here. But basically that's the correct approach, and it's just essentially a question of how accurately do you work out the various terms. The various terms would be, you call this point B. So you would have to work out B, Z. You would have to work out that distance. You would also have to work out the distance from here to here for the little mass, I, Z. And then you'd also have to work out the distance from the center point to that point, which would then be I. What is this point? Okay, whatever it is, let's call it Q, whatever it is.
But it wasn't important anyway because this came here now.
That is a valid point. So that is the tricky part in the exam.
That's why we had mg divided by 2, because now it's here in the middle here, so
Mm-hmm.
it gives you that length.
No, 1 second.
When it's here, it's mg, but when it comes here, it's mg over 2. right there. So when you take your moment, then you take y, I.
No. This is just a rod.
Yeah, isn't this is a plate?
Yeah, that's a plate.
And then it's in the middle of the plate.
Yeah, so the force is coming over here.
Yeah.
So I need this distance. I don't need this distance. I need from here to here because I'm taking it at the equilibrium at this point. So at this point, the force times the perpendicular distance is from here to here. That's the trick.
Yeah,
There's
but if you take it from here to here, then you don't have to divide it by 2 anymore.
No, you still, it's half of the mass on this side. I can apply equilibrium at the points over here. Okay, let's rephrase. All right? Obviously, it's symmetric. The same thing is on this side. So, okay, let's do this. Let me get my eraser. I agree. I've already got the video of your main questions. Okay, you can take a seat. I'll carry on a little bit. Okay, so what happens basically is all right, that's basically a force diagram. All right, so you've got your centrifugal force, that side. You've got your mass, your weight of the ball, and you've got the weight because of the sleeve. And I say take your equilibrium moments at that point over there. Okay, so using your notation, this is point B, this is point I, vertical one, this is point Z. Let's just call this point Q for the sake of argument. All right, clockwise moments is equal to anti-clockwise moments. All right, so counterclockwise is equal to clockwise. What is going counterclockwise? The centrifugal force going this way. So I'll say F, this is the force, and then the perpendicular distance would be BZ. All right, that's equal to the clockwise moments. There's a weight, mg, and the perpendicular distance would be iz. And then the weight, because of the other one, half of the sleeve, and the perpendicular distance would be iq. That's the basic equation over there. So you'll get, if you just write down that equation, you'll get like 10 marks out of the 25, if you can do it. And the rest of it is, what is the BZ in terms of the L1 and the beta and the alpha and all of that. So if you write the basic equation, counterclockwise is equal to clockwise, using the hint, and then you put down that expression over there, I'll give you maybe 10 marks. And then the rest of the 15 marks is how close or how accurately did you work out all of these other terms in the square brackets. So let's see what we can do, and we'll wrap it up in a few minutes. So m omega squared, Now what is the distance? We need this radius. This would be r. All right. What is r? That's a good question. ZQ.
Yeah.
All right. And then I think we'll leave it over there, because then different people will have different notations and different points and things like that. So there's no general answer. It'll get too confusing. But basically that's the general idea. And then if you have a governor, essentially it is trying to give you easy marks to say clockwise moments is equal to anti-clockwise moments. And then using the picture, try and work out the geometrical parameters, the BZ, the IZ, the IQ, and so on and so forth, depending on how you draw your diagram. So the key point is you take the main picture, try and figure out the force diagram, and then just apply equilibrium of moments, and then take it over there. All right, so for question 4, I think we'll leave it over there, and that's the end.